Good morning, my dear kids. In today's class, in the revision of heat and thermodynamics, we are going to discuss some 15 numerical, the different types of numericals. I just brought it. Okay, immediately the question when displayed on the screen, read it in your notebook. Start drawing the diagram. Irrespective of what the topic is there, you have to draw the diagram. Then uh, link to the what topic it belongs. Then read the question, what idea is involved. Then how you can solve this one, what equations you can write. There's every question like this you train up that one, but make a habit of reading 2 3 4 times, fast reading that one. Then immediately the idea involved, then drawing the diagram, then writing equation, then solving, then conclusion, then cross checking whether it's right or wrong. This everything should occur within 2 3 minutes. So most of you, sir, are you bothered now about exam only? Yes. Now I think we should think about exam only. No, we are at a stage. I was insisting knowledge earlier. Now I am insisting on the exams. Read the question. It's all about solving 2 3 minutes is what the skill. I think that's what we should train up ourselves. Everyone is having equal opportunity to improve. Please utilize it. Everyone, irrespective of for your marks in the weekend exams, everything, everyone can do better. There's nothing like a this student, that student, this one. The one who puts effort, he will climb up. I will record. Okay, we have eating plate. Then we have and this is being heated by the heater coil, which will supply the power at a rate 50 watt. Okay, the thermal conductivity of this is K. The top surface of steel plate is exposed to an airstream of temperature. So there is an airstream is there. Just for to make you understand, even if you can just imagine, and there's a airstream. And the temperature of airstream is 20 degrees Celsius. Calculate the rate at which the top surface loses heat due to convection. What is the temperature? Okay, this is heating plate is maintained, so 100 degrees Celsius is the temperature of this. Temperature of this we don't know, theta you call it. So there will be like a heat will pass through this. Heater coil will supply 50 watt of heat. Okay, that 50 watt is what thermal power will pass through this one, and this is a plate. Two plate, steel plate, no, this is. Okay, I think this much is some information is given. Okay, let's go for the what all the heater coil will supply. The heating plate will transfer to steel plate, so this H should be equal to 50 watt. And what is h? Should be equal to Ka 100 minus theta by this d. This should be equal to 50. With this, I'll get the temperature of the surface of the steel plate. Now the A stream is flowing. What is asking? At the same time, it will also radiate. This will be radiation. The red color arrow will be radiation, and the air which is in contact, no, it will carry on the heat. So what all the now the steel plate loses heat will be due to both the process. So heat loss due to convection plus power loss due to radiation. I think the power will go for it. Power due to convection, power loss due to radiation. That should be equal to the H. We'll use symbol H only. Uniform it will be. So due to convection, this is what being asked. Now due to radiation, can we find out? Due to radiation, it should be equal to sigma area of cross section A theta to the power of 4 minus temperature of this. Let me write theta naught. If he has given any emissivity, we would have written that emissivity also. If telling like radius like a black body, okay, we can put E equal to that one. This should be equal to H. So this is unknown thing. Sigma value we know. Sigma is 5.67 into 10 to the power of 8. Area of cross section 0.03 into theta to the power of 4. Convert this into, we have to calculate theta. 98.75 degrees. You do calculation, I'll just leave it out here. This is 50. Substituting all this, you have to substitute this in Kelvin here. I'll better write Kelvin. (10 to the power of -8), no? Okay, fine, yeah. What is T? T is equal to theta plus 273. T naught is theta naught plus 273. I think we do go wrong here also. In exams, no, directly we'll substitute the degree Celsius. Solving this, we'll get the power loss due to convection. Small idea. So what all that the air particles, air molecules, when they come in contact, they will like a drag that heat from the surface. The air molecules which are will come in contact. No, what happens? They will absorb the heat from the surface of it. That is what happens in the convection. Nothing to do. We need not to go in depth about anything convection here. Somebody should give me the value H. This will be your answer. Cross check later on calculation. Read carefully. Some condition he has brought it here. Now, heat received by the Earth due to solar radiation. Heat received by the Earth due to solar radiation is 1.3 kilowatt per meter square. I think this is nothing but the intensity of sun's radiation at the surface of Earth, or what you can call solar constant in the book. Instead of calling solar constant, they say again heat. Again, you'll get confused with the word heat. Look at the unit. Kilowatt per meter square. Nothing but the intensity. But the terminology can be used. Be careful. Such things happens more in mains exam than advanced. In advanced, they say intensity of sun's radiation on surface of it. Clarity will be there. But in mains, what happen? They can express like this also. So this is nothing but the intensity of sun's radiation on surface of the earth. Not like a joule here. You see the unit. Now, earth crust increases for every, the temperature of the earth crust increases 1 degree Celsius for every 30 meter of the depth. Average thermal conductivity of earth is given, radius given. Calculate the rate of loss of heat loss by the earth's core due to the convection. Suppose if you look at this, each surface, so we'll assume a surface like this. Let this be x, thickness be dx. Then what actually happening here? Now the temperature of this, let it be T. The core, what will happen? The temperature of core will be more, no? So there will be flow of heat in this direction, because the core will heat up. And we do have here a sun, which will be radiating, and all the radiation, I'll make it some. No, is it all the radiation emitted by the sun will fall on it? No, only a fraction of it. Only the radiation which lies in this cone will be incident on the surface of the earth. Okay, this is the sun. Just I'm trying to explain some concept involved. Everything will cover it here only. So let the R be the radius of it. So what all the earth receives the heat energy. So what will happen to it? So it's telling like the core will, the crust, earth crust increases 1 degree Celsius for every 30 meter. So definitely what all the earth receives the heat from the sun, a part of it is used to rise the temperature of the core. So there will be flow of heat and the thermal conductivity of the earth's material given. So we can think in this way. At the same time, we have to check it like, will it also radiate? Yes, it will also start radiating, because the surface of the earth will behave like a black body. So what all the power received from the earth's sun's radiation, a part of it will be used to rise the temperature of the core through the conduction of the earth material, and the remaining what happen will be converted as radiation. I think that there's overall idea of the problem. Now first part will come for this one. Calculate the rate of loss of heat by the earth's core due to convection. How to find out this? I think the average thermal conductivity, there's a thing for every 30 meter of the depth. So I'll go for the power loss due to core, or the heat supplied to the core per second. So this should be equal to K into 4 pi r square dt by dx. This information is given. He has given that average, k average he has given. Okay, I'll directly use this formula. But k will be different at different points. He said altogether k average. Okay, we can use this formula. Okay, there is a power loss due to the core. So shall we write x square or r square? This is one more important. Directly given dt by dx is given. So we directly take, what is the effective area here? Here it is 0, here it is unknown. So from here is there will be flow of heat, that one. So 4 pi r square only we have to take it because k average is given. Okay, there's the one thing. Okay, now we know the intensity, this one. So shall we, what is I naught? I naught given is 1.35 k watt per meter square. There's the intensity of sun's radiation on the surface of the earth. Now the power received, power incident on the earth equal to power that is utilized to heat up the core plus power emitted by the surface of the earth. Power incident should be equal to I naught into what is the effective area, will be pi r square. Or shall I write 2 pi r square? No. You have to write effective area as pi r square only. Effective area as seen by the sun's radiation. Effective surface of the earth as seen by sun's radiation. Not 2 pi r square. Because the distance, this will be very large. This should be, this already we have calculated. What to do? Power emitted, sigma 4 pi r square into T. Estimate the temperature of its surface. TE, I'll write it. Substituting all, I think r square pi r square get cancelled. So I naught equal to 4k dt by dx 4 sigma TE. I don't have answer here to calculate and predict this one. Anybody give me the value? Temperature of earth. Okay, I think that's very important. Suppose if there is a, we neglected this part and we discussed, but actually the earth also, what happened, there will be conduction of heat in radially inward direction. In books what we discussed, so possibility of in advance introducing this concept, that's why I just brought it here. Okay, you do calculation. Yeah, read the next one. Something is bringing, so we have a truck. Let's see that what actually the conditions that are there. So it is here's the wheels. This one you'll put a brakes. That one. So now what are the conditions? So the weight mg sin theta. We'll just proceed with the basic things what we know it. Then the air resistance is asking to neglect. So if he has put brakes, so what is the state of the truck? Will it slide or roll? I think we should really go back to the little bit of rotation mechanics here. The only other dissipative force apart from the brake force on the truck is the air resistance force that is equal to F. Okay, okay, fine, fine. Air resistance is dissipative force, that is okay. Then, what about the sliding or rolling? Air resistance, okay, I read it, I read it. Somewhere equal to F. Now, what about the sliding or rolling? What should be the state of the truck? Yes, put up a brakes and the friction act here such that it will be rolling friction. And what is the net work done by the rolling friction should be 0. So though if I show the rolling friction, net work done is 0, that one. So this is what happens. Now, what all the decrease in gravitational potentiality, what will be converted? There will be some brakes, the bushes that will come here. They will apply the so that retarding torque, and in fact they will consume that energy here now. Now the decrease in the rate at which gravitational potentiality decreases, mg sin theta into v, that should be equal to power dissipated in the brakes plus power dissipated to overcome the air resistance. Air resistance directly given F into V. A truck of mass m has 4 wheels. Okay, we'll do one thing. M plus m, no? I think mass of the truck. Okay, we'll do one thing. It will be, there's a situation. So if you want, you can total truck of mass m has 4 wheels. The total along with everything, total mass of the truck should be the m, that one. And the mass of the truck will be definitely greater than mass of the wheels. There's no doubt. Okay, this like this will proceed here. Mg sin theta into V equal to power dissipated by the brakes plus power dissipated by the air resistance. Now proceed like this. What is the power dissipation by the brakes? Find the initial rate of rise of temperature of each metal disc after the brakes are applied. I think this what I'm asked. This what I'm just carrying on this one. To find the final temperature of disk, assuming that it is a blackbody and loses heat only through radiation. I think there's a second part of the problem. We are going to bring into the radiation into the picture. Okay, first part, let me do it. What shall I do? Power lost means altogether 4 wheels be there. 4 into mass of each wheel, specific heat capacity he has given S, then dt by dt. Find the initial rate of rise of temperature. Small m it should be. Why 4? 4 wheels are there. So we have to just solve now. Mg sine theta minus f v equal to okay, fine. Okay, this is about the part A. What about the part B? Part B will be find the final temperature of the disk assuming that it's a blackboard and loses it only through radiation. It will have temperature T. Surrounding temperature is say T naught. Now this will become sigma. Area of cross section is given. No? Metal disk in each wheel is a sigma A T to power of 4 T naught to the power of 4. This should be equal to mg sine theta minus f into v. So we have to solve for this T. Here you should not bring capital M. I think this was the mistake what we do. Who is going to dissipate the power? Only the metal disk which are there here. Small m will write it here. Capital M is total mass of the truck along with the wheels, everything. So you should not write again here capital M plus 4 small m. I think you'll be M is the mass of the truck means what pen? Even the mass of the wheels are also included. I think you have to be careful. Srivastava, you should mention Stefan's constant. You should have the basic idea. By the time radiation means it's understood, no black body. You need not to think in that way. The moment you see radiation, you are supposed to carry on. So don't expect all these things, especially in exam. Okay, simple. This one. So usually the mistakes what we do here only. Capital M plus 4m. This was the one primary mistake what we do it. Now one more thing. In fact the friction acting will be rolling friction. Due to rolling friction, the net work done by rolling friction 0. You need not to bring the work done to outcome the rolling friction. Net work done by rolling friction will be 0. I think this is one important parameter here. I don't know what is divided by 4. Oh, here, this one. No, find the final temperature of the disk, assuming that it's a black one loses heat only through take atmosphere. This everything. The four will be there here. Yeah, I made changes. We have a rod. Let me take help of same diagram. The first situation. So let me take a point. let me take a point P1. Okay, this part of the rod, let it be like this. So there's a point P1. So there is a point P. Okay, sorry, P it is himself is telling. Find the distance of this point from the lower end of the rod. Okay, let this point be at a distance L1. The total length of the rod is L. Then it's telling like there is a point P on the rod which will not undergo displacement. Is asking to get the location of that particular point. There's a basic idea of this one. So this point P will not move means when you rise the temperature, it will try to expand. So this AP will try to move down, and PB will try to move up. So how the friction on the lower part should be upward. On this upper part, it should be downward. Sir, we are not understanding the way you are writing the frictions here. There's a point P which will not shift. Then when you rise the temperature, the lower part has to shift down. Then the inclined plane will oppose the motion of it. So therefore the friction will act on the lower part AP up the incline. The upper part, because the point P should not shift, means the upper part as you rise the temperature should move up. Then the friction act will act down the incline. Sir, why we should think in this way? Why can't it be either way? See, the question is that there is a one point on a rod which will not shift, means then either side of that point open should have a displacement on opposite direction, because altogether when you rise the temperature, the length of the rod should increase. The length of the rod should increase. So therefore on either side of the point, the displacement of the material should be in opposite direction. So therefore first, for equilibrium, F1 minus F2 should be equal to F2 minus F1 equal to F2 plus mg sin theta. What is F1? Total mass of the rod will be m by L L1 into mu. This is F2 will be mu m by L L minus L1 g sin theta plus mg sin theta. Cos theta, sorry, cos theta. I'm writing directly since you know most of the things. All we'll do one thing. N1, L2, I'll write it. What is N1? Normal contact of this part. This should be equal to M1g cos theta, M2g cos theta. I will write in, this should be equal to mu n N1 mu n2 plus mg sin theta at equilibrium. This should be equal to m1g cos theta mu m2g cos theta mu, or this is mg sin theta. What is m1? m1 should be m by L L1 g cos theta m by L L minus L1. Solving this, we'll get expression for that L1. mg get cancelled, so this will be mu L1 2 mu L1 cos theta equal to mu ml cos theta m also will get eliminated, no? M will not be there, so mu cos theta plus sin theta. Okay, now we have to solve for L1, so there should be L by 2, L by 2 plus this will be L by 2 mu tan theta. Check once. Okay, this will be our answer. So final answer. Okay, somebody give 7L by 8. Yeah. Okay, then. Now, similarly, if the temperature falls, the rod contracts. Rise in temperature. What we discussed this is. Next, we'll discuss for fall in temperature. Just simple condition he has brought it. So let there be a point. Now, what conditions will occur here now? The part AQ will move up, part QB will move down. When temperature decreases. Please don't ask some stupid questions, sir. Sir, there is no use of thermodynamics, sir, only mechanics. I don't know what to reply for this, the way you are asking question. Mechanics is a general subject, will come everywhere. No, there is no thermodynamics here. Without thermodynamics, how that elongation, contraction? Please don't trouble me with those stupid questions, at least. Okay, now there's a point. If the temperature falls, the rod contracts. Once again, there is a point Q which it does not move. Find the distance of Q from the lower end. Okay, we have to calculate this distance. Less interested in learning, more interested in other things. Now, what will be the AQ? AQ will move up, so the friction will act down the incline. F1 dash you call it. Here the friction will act up the incline due to contraction. So let this be L2. Okay, now again this will be N1 dash, N2 dash, M2 dash G cos theta. You look at your advanced paper, 80% of questions are mixed concept. Tell me, shall I train for you advanced or shall you train for according to your wish? Srivastava? That's why I told you in the beginning, no, keep out your emotions. What is advanced paper is there. Based on that, you should train off yourself. Keep out your egoism. If you don't surrender your egoism, not possible. That's why in the beginning only I told you, these are the many things will come which you may not like, but finally your goal is to get better rank in advance. So prepare for that. Finish over. F2 dash equal to f1 dash plus mg sine theta. f2 dash should be equal to mu m2 dash g cos theta mu m1 dash g cos theta plus mg sine theta. Now mu m2 dash will be m by l minus l2 g cos theta solving will get expression for L2. Now look at the last part. Will the repeated expansion and contraction cause the rod to slide down? Yes or no? Anybody wants to? This is a very important. A student should analyze. Which will be greater, L1 or L2? I think that finally matters. Anybody value of L2? Okay, yeah. 1 by 8. Now which will be what actually happens? Repeated expansion and contraction cause the rod to slide down, slide up or slide down. Students should answer the last part because you have to analyze now. I'm displaying the total question. It should slide down, no, in one cycle. Why it should slide down means you can see the point P is at a distance 7L by 8. Here this lower part will move down. Here the L by 8 will move up. Then the next when you decrease it, again you see this L by 8 will move down. 7L by 8 will move up, but which will be more? The point Q. The point Q is nearer, no? Here. This part will move up, this part will move down, no? The net you can see that one, the 7L by 8 is what moving down. Simple geometry. The Q is here, no? The Q is here, that one. The segment which is having longer length, it is having more displacement. It is having the downward displacement. So therefore, it will move down, that one. Will the repeated contraction cause the rod to slide down? The answer is yes. A simple mass based one. Analyze it. Very fast, we'll speed up. So I think everyone got settled. Now we'll speed up things. Okay, this is a P, this is A, this is C, this is theta. Tan theta will define it. Tan theta is equal to AP by AC. Sorry, CP. Let me take log of tan theta equal to log of AP minus log of CP. No, let me differentiate this. So this will be secant square theta by tan theta d theta. Log of AP, derivative of AP by AP. This should be equal to AP will give the something alpha y is AP, no? So alpha y delta t. And what about the CP? CP will give alpha x delta t. So alpha y minus alpha x delta t. Theta is given for us. Theta is some value here. D theta. Oh, look at now. So what is greater? Alpha x greater than alpha y. So therefore d theta will decrease here. Some mass based questions, especially for advanced. So we should analyze here. There's no other way. Different types of questions will come. You have to be careful. Thermal expansion. Just by seeing, we should not supposed to conclude anything here. Any mass is involved, take help of mass and conclude. Now, how come this I'm writing here? So we know there's a formula delta L equal to L alpha delta T. So delta L, fractional change in length should be equal to alpha into change in temperature. Therefore this equation is applied here. Okay. These are very dangerous questions. So even as a teacher, we also find very difficult, because we have to conclude based on mass. So you should not use any other method, I feel here. So something, the information given, so take help of that and try to analyze. Now this is about the wall. Yeah, this one. If there were no walls were not there, then what would happen to the rod? Due to rise in temperature, it would have expanded. Shall we take like this? It would have expanded, but the walls will not permit. So therefore now definitely will there be any normal contact S, normal contact N, and this N, this N, this N. So earlier temperature, let it be T1. Now the temperature is T2. Theta 1 I'll take it. Theta 1, this is T2. So this was the length of the rod. So definitely it got elongated now. What is the minimum rise in temperature so that the rod is in equilibrium? Now if the walls were smooth, the rod will fall down. So definitely because of the friction, what will happen? The rod is able to balance its weight and it's in equilibrium. First of all, for the friction to act, there should be normal contact. And there's a friction at both the walls are there. We'll see that one. And it's telling friction for one wall is 2 mu, coefficient of friction for one wall is 2 mu, other is mu. Now I'll proceed like this. What is delta L? So let's go back to thermal expansion, L alpha delta theta. Then we know Young's modulus equal to stress by strain. Here stress is normal reaction per unit area by strain. The strain is alpha delta theta. So N is equal to Y sigma, or time being I'll write it here. Sigma is N by A Y delta L by L. So this will be N by A, Y delta L by L is Y delta theta. So N is equal to Y A alpha delta theta. Okay, this is the normal contact between the wall and the rod. Okay, after getting this normal contact, then the frictional force. Yeah, the frictional force. Now, let this be 2 mu, let this be mu. What to do with that? What is the minimum rise in temperature? What should be minimum rise so that it's in equilibrium? So at one wall, the frictional force acting, if it is limiting, at other wall it should be static, because the 2 mu, what is the limiting friction at this point? 2 mu n. Here it is a mu n. So here minimum rise in temperature means, as here if it is a limiting node, this should be static here. Will they be equal? Next question. Yes, it should be. What is FL? The same friction should act here for equilibrium. So this F should be equal to FL in fact. So this will be limiting, that will be static. So therefore F plus FL equal to mg, or this is F plus F equal to mg, 2F equal to mg. What is FL? This will be mu n. What is n? We have a formula, 2 mu y a alpha delta theta mg. Further, what is mass? What is mass? Mass of the rod is given density area into L G, 2 mu y a alpha. One a get cancelled, so rho g L by 2 mu y alpha. Okay, this should be the minimum rising temperature for rod to be in equilibrium. Questions are very easier, only that idea should flash for us. Make observation, I'll go for the next one. Carefully analyze. Spring we have brought it. The rod is permitted to expand also, no, but not completely. Look at the role of the spring here now. Now previous problem, the walls will not permit for the rod to expand. Whereas here what will happen? If you rise the temperature as the rod wants to expand, the spring will oppose. But is it, there won't be any change in length of the rod, as there will be change in length. Let me start with the diagram. This is a rod. Okay, we have like this. Now when I rise the temperature, the rod really wants to expand it. At the same time, if the rod expands, the spring will undergo compression. The spring force will also come into picture. So definitely the elongation, the rod will be less than the elongation due to thermal expansion what it should have. So here I'll go for a diagram. There's the initial, no? This is some very important thing I brought it. This was the initial length. The rod actually wanted to expand till here, but it is permitted to expand, and this is the expansion of the compression of the spring. This is the elongation of the rod due to rise in temperature. This is temperature T1, this is T2. If the spring were not there, the rod would have expanded till here. But because of spring force, the rod is not permitted to expand till here. And look at the spring, it got compressed. So what is actually the elongation of the rod now? Delta L minus X. And this is L naught. Hope everyone is able to understand. It's a very simple. The diagram is very important. Once you can get this diagram, rest of everything you can manage. No, what was the question that is asked? Then the stress developed in the rod. Stress developed in the rod. Stress means the force set up in the rod. Let me go for change in length of the rod. Change in length of the rod. This should be equal to L naught alpha delta theta. Let me use delta theta only. Minus X. This was the change in length, no? Delta L you call it. Now how you define Young's modulus? Young's modulus should be equal to stress by strain. Now who will balance the stress developed in the rod? The spring force. The spring force will act in this direction. And the stress developed in the rod will be F. Let's call this one. So what should be the stress here? Stress should be equal to Y into strain, will write it. Strain will be delta L naught delta L by L naught. Y into L naught alpha delta theta minus x. Okay, this was the stress. So the stress, what you write, F by A. Y L naught alpha delta T minus x. So for equilibrium, at equilibrium, F should be equal to Kx. So what is F is equal to Ya L naught alpha delta theta minus x equal to Kx. Okay, all together I'll find out the value of x. The value of x will be L naught alpha theta minus x equal to K L naught Ya x. So many symbols. Okay, we got the competition, the spring. Then I will equate like this. This F should be equal to Kx at equilibrium. Now I'll substitute the value of this. K is equal to yeah, KL naught plus Ya. Check once, sir. Stress is asking, no? F by A is what the stress? Yeah. This is very important formula because most of the numericals what we picked up is all the rod will elongate or rod will not elongate. Here it is having a partial elongation. It is not permitted fully to expand. That's why I just picked up this problem. What all we have thermal expansion is either the rod will be permitted to expand freely or will not be permitted. But here partially it is allowed to expand. This is called like a yielding of the rod. If you look at the civil engineer, no, we just call this as a yield. I think it's all revolves around this diagram. I feel like everything revolves around this diagram. Somehow student can get this diagram. You can write this equation. What actually goes on here? The rod wants to expand. Okay, the spring will oppose it. Definitely, the rod is not permitted to freely expand. So therefore, the total elongation of the rod should be less than the free thermal expansion. This is a background. If it is there, no, then okay, fine, you can manage. Let me take the next one. I'll read it a little bit. A glass tube of length 130 and of uniform cross section is to be filled with mercury so that the length of the tube unoccupied by mercury remains the same at all temperatures. If the cubical coefficient of expansion for glass and mercury are, this is 10 to the power of minus 5, it is 2.6 into 10 to the power of minus 5. Calculate the length of mercury column. let's remain the same at all temperatures. Okay, let's go for some rough diagram. Okay, here mercury is there. Now it will expand such that the length unoccupied by the mercury remains same. So the glass will expand, so its area of cross section and length both will increase. You can see here. But I have to show that the length unoccupied remains same. Length itself, not volume. The condition is then not the volume, that one. So the first, the length, this is L naught. Length of the mercury be x naught. This is the mercury. Okay, the area of cross section. If you take the radius earlier, area of cross section, I'll indicate. This is A naught. Now it will also expand. So the new temperature, the length of glass tube at new temperature, let it be LT. Length of the mercury column, let it be XT at the new temperature. This is 0 degrees Celsius. This is T degrees Celsius. I have a diagram. At least you can manage now. The delta L should remain constant. What was the delta L? The same delta L. Not the volume remains constant. Length unoccupied remains constant. I think this is the information given. Afterwards, it's all mathematics. So looking at the second diagram, what is delta L? You can write it as LT minus XT. What is the length LT? Should be equal to volume of glass by area of cross section of glass at T degrees Celsius, minus what is XT? Volume of mercury by area of glass at T degrees Celsius. So what is AT now? Area of cross section of glass at T degrees Celsius. Not of glass only it is. So this delta L remains constant. Okay, let me further put all this on. What is the volume of glass? How you write it? This should be equal to volume of glass at 0 degrees Celsius into 1 plus 3 times of alpha G into T by area of cross section of glass A naught E G naught. Let me take the uniform symbols. A G naught minus volume of mercury. Volume of mercury will be okay, this has to be A naught one plus 3 gamma Hg T. Let's see what all we can simplify. I think this will be simple by binomial expansion. I'll end up this much, because what is Vg naught? Further you can write it as if cubical coefficient yeah, 3 alpha I made changes. Okay, this will become Ag naught L naught VHG naught should be equal to this should be A naught, X naught, AG naught 1 plus 3 alpha Hg minus 2 alpha G into T. This will become only 1 plus alpha G, so this will be X naught. Gamma, okay, this is some, not 3, better we'll write gamma. Liquid, no? Liquid we should not write alpha. You have to do, you binomial expansion. So alpha G into alpha G, the product of that will be very small. Gamma Hg minus alpha into 2 alpha G. Again, if you take the product, will be very small. Finally, we'll get this much. Okay, this delta L should remain constant. So delta L should be equal to 0. Now equate this to 0 and solve it. L naught is what needed, no? So delta L should be constant. Or delta L must be 0. So therefore L naught should become X naught 1 plus delta L is L naught minus X naught, no? Okay, so, fine. Here. I think we need X naught. So now we have to solve this equation minus of this. Check now. X naught T. T get cancels, huh? Okay, T also get cancels. Yeah, fine. Okay, anybody give me the value? Both mercury as well as the glass will expand. Both mercury as well as glass will expand. That we have expressed here. Cubical expansions are given. Be careful, huh? Something even if cubical expansion, this is gamma with the cubical coefficient of expansion for glass, and this one alpha will be 3 times of 1 by 3 times of this value. Okay, 7 centimeter approximately. 18 will come. Okay, yeah, fine. Slowly we'll move to the other side. Thermodynamics will come. We'll take few problems on thermodynamics and KTG like that, so that we have touched all the, except calorimetry, I think we have touched. No, calorimetry also few problems we have done. No? Every day, no, just pick up. Don't divide like this. One day KTG, one day radiation. Don't do like that. Pick up some 20 numericals from all the ideas and start working. Like a one day Monday, one day kinematics, one day thermodynamics. Don't do like that. The very first day, what happened? Pick up some 20 different numericals from all different topics and start working out. The intensity of the gas. 1 mole of ideal gas is an intensity given by U equal to U naught plus 2 PV, where P is a pressure and V is the volume of gas, U naught is a constant. The molar heat capacity of the gas at constant pressure is. Now intensity is what given for us, U naught 2 PV. U naught is some constant, it is. Okay, now intensity, what we can write, N CV, or this everything I'll write AT. What is A? A should be equal to N number of moles. 1 mole is given, R by gamma minus 1. The value of that is A. Instead of writing every time, let's have like this. In the end, if you want, we can replace. Now this T is equal to U naught by A to PV by A. What he is asking to get the molar capacity. So let me use ideal gas equation, PV equal to nRT or PV equal to RT. So this will be U naught by A 2 by A. What I'm replacing? P is a constant he has given, no? Okay, no need to delete that. Okay, this let's go for molar capacity. Q by, it is defined as delta T. Q equal to Q, what you can write it as, Q equal to U plus W by delta T, or U by delta T. Further molar capacity, U by delta T, or delta U by we'll take it U by delta T, that one. So this should be equal to R by gamma minus 1. That is equal to A only. A plus W by delta T. W is what? P dV. P anyway himself has kept constant here. So we'll calculate now delta V by delta T. So we have equation delta T is equal to 2 by A P delta V. So delta V by delta V is equal to 2P by A. Now substituting this, A plus, we have to substitute, let me simplify one more. A by 2 is equal to P delta V by delta T. A plus A by 2. 3A by 2. What is A? A is R gamma minus 1. So 3 by 2 R gamma minus 1. Monoatomic gas you should have given, no? One mole only given, no? If it's a monoatomic gas, we'll see what do we get. Monoatomic gas gamma will be 5 by 3. So C is equal to 3 by 2 R 1 by 5 by 3 minus 1. 3 R by 2. 3 by 2. R by 4. So 9R by 4. Check once calculation. I think I'm A plus delta V by T. He has not given monatomic or diatomic. If he gives gamma value, okay, we can verify this. No information gamma. Okay, I'll do one thing, question a little bit. Yeah, we'll have this much here. Now, if it were monoatomic gas, it would have been 9R by 4. Okay, you see that P constant, that will be really troublesome. So where all it encounters, you have to deal in this way. Delta U, okay, fine. You mean to say delta U. Again, delta U by delta. Delta U equal to A delta T. Delta U by delta T will be A only. Check it. Yes. Okay, some changes. Because the intention, change in intention has to be there. I wrote directly. Nature of gas he should give. If he gives nature of gas gamma, then we can further simplify it. Okay, let's have one more. Check once per PVT how you pressure is constant, it's O, no? Check equations, pressure is constant. That's what you have to take care. No. Molar capacity for an ideal gas is going through a process given by the molar capacity also. I think we have very few problems where the molar capacity, almost most of the numericals, what is there in the books, no, there is a constant, but in fact it's a variable also. It can vary with pressure, it can vary with temperature, it can vary with volume, it can vary with intensity. So what is the basic definition? C is equal to dq by n dt. One mole of gas, this one. So du plus dw. Okay, this will be an dt. Du should be equal to nr by gamma minus 1 dt. Work done is asking. We'll proceed in this way. This will be an dt by dt minus nr. I think very simple this is. Temperature varies by eta times. So T naught, eta T naught, T naught, eta T naught. An, work done by 1 mole of gas. 1 mole of gas. Okay, I think I should remove this N. I'll remove that 1 mole. So this will become A log T T naught eta T naught R by gamma minus 1 log T T naught eta T naught. Log of eta T naught minus T naught minus R by gamma minus 1 . This we have to further simplify. Log A minus log B, this will become log eta only. I'll make some correction. Minus dt. nr dt only. R by gamma minus 1, this will become eta yeah, okay, fine. This will become T naught okay, this will be the work done. Can we find out the equation for the process? I think this will be really troublesome because previous problem you see that I gave equation as molar capacity. From molar capacity I can ask you to go and find out the equation. We have to bring how pressure, volume, temperature are related in this particular thing. Tryout can be asked in exams of that kind also. They give molar capacity, they'll ask you to calculate the equation of process. Usually most of the problems what we have is they give equation of process, you have to calculate the molar capacity. But they can ask you in either way also. Okay, now you have to work out from the books what you have gathered. I'll post today assignment. Total complete data thermodynamics, I'll post the assignment and start working numericals from them. Okay, let me end up the class first. Okay, kids, like we had the discussion on the some numericals we have picked up, and we try to revise some basic all the different ideas, that one. So pick up the numerical, start thinking on them, start analyzing it, then recollect the concept, not like reading the theory. This will be the wrong method, is what I suggest you. Like directly take the numerical, start thinking. If you know formula, everything concept, okay, fine. If you don't know formula concept, go back, recollect that idea and work out here. There's a one way where you can save plenty of time just mere reading theory, so that you can focus more on the numericals. Okay, thank you all of you.